There are two requirements that make a probability distribution. One is that the sum of the probabilities must be equal to 1. The other is that all the probability values must be between 0 and 1. That means we can have no negative probability values and we can have no probability values greater than 1. So let's look at this table and determine, is it actually a probability distribution? Well, the second requirement is met. All the probability values are between 0 and 1. But is that first requirement met? Is the sum of the probabilities equal to 1? So let's take our calculator, add those up, and we get 0.998. Well, 0.998 is not equal to 1. So we say no, it's not a probability distribution. And we can abbreviate that statement. Okay. Now, in real life, holding it to a strict, perfect 1 is unrealistic because when we're finding probability values, we sometimes round, and those roundings create errors when we create the probability distribution, makes it to where it will not add up and be a perfect 1. However, for our purposes, whenever you're asked to determine is it a probability distribution, make sure it adds up to exactly 1. That's going to be the rule for us. Next example. Does the probability of x equal to x over 3, where x can be 0, 1, or 2, determine a probability distribution? So let's look at that. Let's build a probability distribution. We have x and then the probability of x. Well, it said x is 0, 1, and 2. And if x is 0, 1, and 2, then we're going to substitute in for x to find our probability. So 0 over 3, 1 over 3, and 2 over 3. Well, 0 over 3 is just 0. So the two requirements are met. All the values are between 0 and 1, and they add up to 3 over 3, which is equal to 1. So the answer to this question is yes, it is a probability distribution.